Here we go. All right, so practice exam number 3, the long-awaited. Practice exam number 3. How similar will the real exam be? Nothing like this. No, I'm kidding. Same kind of questions anyway. 15 questions just like this. All right. Sociologist develops a test to measure attitudes towards public transportation. 27 randomly selected subjects are given the test. Their mean score is 76.2 and their standard deviation is 21.4. Construct a 95% confidence interval for the mean score of all such subjects. Okay, so let's go find it. So back here I've got the exam 3 notes. There they are. So this is the exam 3 notes, which you also have. This is exam 3 notes, backside page 2. And exam 3 notes, the very last part. Okay, so looking here at 2B, that's what we're talking about, huh? It's a mean. This is all confidence intervals. The front side of the sheet is confidence intervals. The back side is hypothesis test. Confidence interval mean. Is it no data given or data given? No data. Yeah, there was no data given on that one, huh? So it's right here is our steps. T interval, choose stats. We have so many different things we do. So let's go back. So we're going to go to T interval. And when it says data or stats, we'll pick stats. And it'll ask us for mu0, x bar, x bar, s sub x, and n, I think is the stuff it wants. So mu0, oh no, not mu0, I'm getting confused. I better, x bar, s sub x, oh, n number, yeah, n number. And number, right, so x bar, their mean is 76.2. S sub x, standard deviation, 21.4. And n, 27 subjects. 27 subjects, all right. And so, T interval, it's like number 8, isn't it? 8. And so we get 76.2. S sub x, 21.4. N is 27. Confidence interval, they want 0.95%. And calculate. So I'm getting, when I do all that, an interval that goes from 67.7 to 84.666607. That one, huh? We good? Easy enough? Questions I can answer? Number 2. The amounts in ounces of juice in 8 randomly selected juice bottles are, boom, 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 all those. Make a 98% confidence interval for the mean amount of juice in all such bottles. These are so easy, you're just laughing at them, right? Easy one? So look on your confidence interval notes. What do you do with that group of data? L1, huh? What we always do with the data, we put it into L1. So just drop all that data into L1. Yeah, that's wise. All right, so it's right here, right? We're looking at data given. Data given. Enter the data into L1. This is a confidence interval, mean, data given. Put the data in L1. T interval, choose data. T interval, choose data. So let's go back and do that. T interval, choose data. So, T interval, choose data, not stats. And then it'll ask you for just list and frequency, huh? So you've already got everything in L1 and frequency 1 and then the confidence interval level, which is 0.98, and hit enter. And I'm getting, see if you're getting what I'm getting. I'm getting 15 point, what do they want? They look like they're all 2 decimal places. 15.32. comma 15.91. Oh yeah, there it is. All right, we're rolling. Pretty easy so far? All right, on we go. How many commuters must be randomly selected to estimate the mean driving time of Chicago commuters? We want 90% confidence that the sample mean is within 4 minutes of the population mean, and the population standard deviation is known to be 12 minutes. All right, so what is this? It says sample size right there. Sample size. Where on our exam 3 notes do we see anything about sample size? Yeah, well done. Number 1 is sample size, right? Number 1 on the exam 3 notes. So now we have 3 formulas, and we got to discern which one, right? We got this one, and this one. How do we know? Well, it's about whether it's %, or is it mean? That's the first distinction. Which one is ours? Let me go back to it. It is, mean. There it is, mean. So that's nice. So once you know it's mean, there's only one option left. There's only one for mean. It's that one, huh? So that's the one we use. And notice words here, very important words. Round answer up. A few people have asked me, it's a good question, which ones, Mr. Heron, do we round up? Because they remember there was something, but it's not everything. Yeah, it's these, and it'll say it right on your exam notes. So if you want to highlight that for yourself on the notes or underline it or whatever works for you, but somehow make sure you notice that, because that means round even like a 0.1 up, huh? That means everything up. It's these. All right, let's go back and do it. So that's N equals Z times S over E, the whole thing squared. Now, how do we get that Z? It also says it on the notes, exam 3 notes. It says inverse norm, double parentheses, 1 minus confidence, divided by 2, comma 0, comma 1, and hit enter at the end of that. And our confidence level on this one, 90%, 0.90. So put that into your calculator. Now remember how this works. Is the Z itself being squared or the whole thing being squared? The whole thing, obviously. So don't hit square right now. You just finished Z. You just have that part on your calculator right now, right? You need to next go times the S divided by the E. And then and what is the S? The S is, standard deviation is 12. And the E, how do you know what the E is, the error amount? Within. I put that on the exam 2 notes. You notice I put error within to help you, to remind you they usually use the word within, because you want to be within that amount. That's the error amount. So that's your 4. And then remember, you have to hit enter right then. Why is that so important? Because that makes the calculator calculate all of this right here. The Z times S over E. It gets the whole thing. That way when you hit X squared as your next button, it squares the whole thing. If you didn't do that, if you skipped that enter on accident and you hit the squared right after the E with no enter, it would only square the last thing you put in rather than everything. Do you see the issue? So that's why we got to hit enter and tell the calculator. When you hit enter, it signals the calculator, please calculate everything I've given you up to now. It'll calculate it all, then hit squared, and then you're squaring everything rather than just the last thing. And that should do it. I'll do it too. So it comes out 24.3. Now what do we do with that number? Round up, as it says on your exam 3 notes. Even 0.3 goes up to 25, and there's our answer. All right. This exam is easier than the last, but there's harder ones to come. Questions on that one? Question 4. Margin of error, 0.07, confidence level, 95%. From a prior study, P hat, it's funny that's called hat, but it is, P hat is estimated by the decimal equivalent of 92%. Use the given data to find the minimum sample size required. to estimate the population proportion. So what do they want from us here?
Sample size.
It's another sample size, isn't it? See how they're saying sample size, and they're all, like normal integer numbers, So let's go back to our exam 3 notes. So it's number 1 somewhere up here. But which one is it? Is it a percentage this time? Let's see. Yeah, this is number 4. Yeah, we're talking about percentages, aren't we? Right? Population proportion. And they're giving me a 92%. We're talking about p hat. So definitely proportion. So there's 2 kinds though, aren't there? There's unknown and known. Do we know anything about any p-value on this one? Yes. Yes, we do. Let's go back. Right here. P is estimated by the equivalent 92%. So they're telling me p hat is 0.92, aren't they? So this is the known. We know something. We have an estimate for what the proportion might be. It might be close to 92%. When you have an estimate, right, that's like you're about to do a study on something, whatever it may be, what percentage of people, go to some kind of college in their lifetime. 92% of the population. We think it's about 92% of the people in the Central Valley go to some kind of college and take classes at least at some point. So if you have an estimate, that's the other formula. So getting to that form, that's the one that says n equals z squared. Oh, no, it's the wrong one. Z squared times p times 1 minus p over e squared. That one, that's the known formula. So, and you know how to get z. Z is inverse norm, double parentheses, 1 minus confidence, divided by 2, 0, 1. Like that. Hit enter. And then you keep going. And what are we going to do next now? So that's the z. That's the z right there. And so is just the z squared, or is the whole thing squared? Just the z, and eventually also just the e, huh? So we square right after them, don't we? Rather than at the very end, hit enter, and then square the whole thing. See the difference? So we're wanting to square just that z. So I'm going to hit x squared right now, and then I'm going to go parenthesis p, and parenthesis 1 minus p, and p is 0.92. 0.92 and 1 minus 0.92. And then divided by e, and then hit squared right after the e. And what is e? Yeah, air is 0.07, huh? 0.07. Hit x squared, and then don't forget to hit enter at the very end, because that tells the calculator, calculate all this stuff now, please. So there we go. There's the keystrokes. What was the confidence level? 95? Yeah, don't confuse that with the P. I'm getting 57.7, which is 58, which is disturbingly not there. Now, did you get that? To number 5. Of the 346 items listed, 12 are found to be defective. Construct a 98% confidence interval. Aren't we done? Another confidence interval, huh? For the proportion of all such items that are defective. All right. You can tell the answers all have a P in them, don't they? So P there. So it's a so we go back to our exam 3 notes. We say, okay, we're talking about that's number 2 down here. It's some kind of confidence interval number 2. And it's a P. It's clearly a P. All the answers had a P in them. So there's our step. It's 1 prop Z interval. 1 prop Z interval. See how you identify these things? So we say, okay, I'm going to do 1 prop Z interval. And when you do, it asks you for X and N. So what is X? Yeah, see how we're trying to find the proportion of defective? So that'd be the 12. 12 are defective, 346 items total. That good? Now remember, when I say this is like the real exam, I don't mean it's lamely like it. I don't mean I'm going to do like exactly the same thing and just change this to a 13 and this to a 345. That wouldn't be fair. You wouldn't want a degree that way, right? That's just handing it to you, right? So that's not what I mean. One of my colleagues used to do that, but I think that's giving away grades. So instead what I mean is there's going to be one question that's a 1 prop Z. So heads up, remember from the homework, sometimes they said things like 12 are defective and 50 are good, for example. It could come that way. We had some of those in the homework, didn't we? So really anything in the homework is fair game. So what if instead of 12 defective, 346 items total, they said 12 defective, 50 are good? What would you do? You'd have to add them to get the total, huh? Is that right? You got to watch out for that?
That's actually the next one.
Oh, okay, thanks. Yeah, I should just wait, yeah. And also, what if they said what percentage are good instead of what percentage are defective? You do have to watch the words. Then your X would be the 50, not the 12.
You should wait until the next one.
Oh, just do that, yeah. So all right, I'll just quit fooling around. So is that what it literally is? Yeah. Okay. All right. All right. So I'm trying to make this one harder, but the next one's already got it. All right. So let's go to 1 prop Z. Whoops, I went to the wrong thing. So 1 prop Z, and it asks you. Whoops, I went to the test. It's 1 prop Z interval. He's confused. There it is. Way down on A, isn't it? So it's X is 12, 346 is in, confidence level is 98%. And calculate. I'm getting 0.0118, comma 0.05757. Which one of those matches up? Oh, it's this one. Yeah. This one's close here, isn't it? That's like close, but it's not right. It's this one. Good? Easy enough? All right, I'll move on to that next one. Number 6. Survey of adults. 61 have health insurance. 31 do not. All right, give it a try. All right. So it's 1 prop Z interval again, isn't it? It's the same thing again, the X and the N. So what's the X now? Is it the 61 or the 31? How do you know which one is the X?
Because this is who has health insurance.
Yeah, you got to watch what they say. Yeah, what do they say? For the true proportion of all adults in town who have. They want you to come up with a confidence interval for the proportion that have. That's the 61. And then you got to add these up to get the total 92, huh? And do a 90% confidence interval. that'll be. And I'm getting an answer 0.58199, comma 0.7441. So that looks like they rounded them all to 3 places. So that'd be 582,744. 582, yeah, right here. 582,744. Good on that. All right, on we go to number 7. An airline claims that the no-show rate for passengers booked on its flights is less than 6%. Of 380 randomly selected reservations, 14 were no-shows. Perform a hypothesis test at the 0.05 significance level to test the airline's claim. What is the conclusion? So notice that this is clearly a hypothesis test. And I'm not asking you for the HO or the H1 or the p-value or the test statistic or reject the null, don't reject the null, but I just do want the bottom line, At least on this one. See how I'm going to test one little thing on each one, usually the bottom line. So, all right, can you set up? So even though I'm only doing the bottom line, you really need to do claim HO, H1. You don't want to skip those. I know there's a tendency to think, I'm just going to put the numbers in and hit the buttons. But you won't know what those buttons mean, what those numbers mean if you skipped claim HO, H1. So do that for yourself. Even I, as I was doing the key for this, had to write claim HO, H1. If there was a way to skip it, obviously I've done a zillion of them, I would do it. But there isn't. You really need to do that. So claim HO and H1, you've got to write those so you know what's what and what the conclusion means. All right, so let me give you a second. So I can go with you to the exam 3 notes. Here we are. On the back side, hypothesis test. First thing is to write the claim, and it's either going to be P or it's going to be mu, equal, greater, less, something like that. So let's go back and see. So where are they actually saying claim? An airline claims. Well, there we go. What do they claim? The no-show rate for passengers booked on its flights is less than 6%. Is that an average or a percentage? That's a percentage. So we're talking about P, aren't we? Talking about P, not mu. Right? Mu is for average. It's the Greek M for mean. And P is for percentage or proportion. And it's less than 0.06, right? That's 6%. Remember to go back 2 places. It's not 0.6, right? It's 0.06. So there's what's being claimed. That's the most important thing. We got the claim. Can you take it from there? So what's HO always? Always equals. So what's H1 going to be?
Less than.
Yeah, one of the two has to match the claim identically, doesn't it? One of the two must be exactly the same as the claim. So it's that H1. So that's the claim. And now what else do we always write as far as evidence goes? Yeah, always weak evidence for the first one. And strong evidence for the second one. Weak evidence, strong evidence, always, in that order. All right, so we know what we're going to do. We can go back here to the notes if you need to. It's probably pretty fresh in your mind. Number 4, hypothesis testing on the calculator for P or percentage. That's where we're at. 1 prop Z test. That's what we need to do on the on the calculator. So let's go there. So come over here. 1 prop Z test. So 1 prop Z test, which is like number 5. And then it's going to ask me for a P0, an X, and an N. What's the P0? Yeah, where do you get the P0 from? Yeah, you always go over to the H0 and grab the number next to H0. 0.06, yeah. The X, what do you think the X is? It's the 14 no-shows, huh? And the N, 380 total people on this one. Right? And then you have to do greater than, less than, or not equal. How do we know which one there? Less than. So whatever. We get that right from H1, don't we? Less than. And then calculate. And all I really care about is the p-value. P is 0.0286. 8, whatever, who cares? That's enough. Well, let's go 0.028. It's just for me. They're not asking for it. So it's just for my purposes. So 0.028 is the p-value. Now, how do we draw a conclusion? Let me scoot that over. Yeah, you have to put the alpha right next to it, don't you? Where's the alpha? The significance of it, right? You got to write the significance level right next to it, which is 0.05. Right? I just took this right here and went right there. And then you got to decide which one of those is bigger. If you want to add a 0 here, that could be helpful. That way they have the same number of digits, which is easier to compare. Yeah, the significance level is bigger, huh? The wide side goes towards the significance, the open mouth, the wide side to the significance level, because he's the bigger one, right? The bigger thing goes on the wide side, smaller one on the narrow side. Okay, so that's all good. They didn't ask me for any of this. I'm just doing this to help myself out to draw a conclusion. So how does that help me draw a conclusion? Yeah, is that P low or is it not low? Yeah, it's less, right? The P is less. So the P is low, isn't it? So, and you know the statement, if P is low, HO must go away. So if the P is low, the null must go. So must go away. So if the P is low, the null must go away. So I've got to cross out the null. Bye-bye null. And that means I'm going to accept the H1. Because it's always one or the other. They're like two attorneys arguing. So if the null goes away, we keep the H1. So there's my conclusion. What's my conclusion? P is less than 0.06, which was the claim, and there's strong evidence. See how we're sure of that? And that all comes from the claim, which led to the HO and the H1. That's why you got to have those to know what that number in the end means. Okay, so therefore, let's read through the possibilities now. First, so there is sufficient evidence. Is there sufficient evidence? Yeah, it's going to be one of those two, not these two, right? We've already narrowed two of them out of there because there is strong evidence, isn't there? See how we know that? Because we rejected the null. The null went away, right? The P was low, so the null went away. So we keep the H1, which always means strong evidence. So there's strong evidence. So it's one of these two. Sufficient evidence to conclude that the true percentage is less than 6%. Is that right?
Yes.
That's exactly right. Less than 6%. Beautiful. There we go. What did the other one say? True percentage is not less than 6%. No, it is. Right? We concluded here it is less than 6%. There's strong evidence for that. There we go. Does that feel comfortable? How you can draw that conclusion with confidence? Look at that. You can look at a claim and weigh out statistical evidence. That's good. That's some college level math skills. All right. Okay. A manufacturer makes ball bearings that are supposed to have a mean weight of 30 grams. A retailer suspects that the mean weight is actually less than 30 grams. The mean weight for a random sample of 16 ball bearings is 28.6 grams with a standard deviation of 4.4 grams. At the 0.05 significance level, test the claim that the sample comes from a population with a mean weight less than 30 grams. What is the conclusion? Again, they just have the words and the final conclusion, don't they? None of the in-between. Sometimes they'll just ask us for the p-value. You'll see in a minute. All right, so what's the claim on this one? Yeah, the retailer suspects that the mean weight is less than 30. So it says mean, so it's going to be mu, not p, right? Less than 30. The mean is less than 30. There we go. Now from there, can you write the HO, the H1, crank it out. So the HO, I better put them down here, huh? I'll do them over here. The HO, oh, there's not going to be room. There. So the HO and the H1. So what's the HO? It's always equals, huh? And then what's the H1 going to be? Yeah, one of the two has to match the claim identically, doesn't it? Always. So you write claim there. And then we got to put in the information about evidence. Weak evidence. Strong evidence. So weak evidence, strong evidence. All right, and now we go to our calculator. So we're talking about mu here. Let's go to the notes. Hypothesis test. This one is down here. It's for a mean. Now, is there data given or no data given? No data given. So we're going to do a t-test and choose stats, aren't we? So we'll do that. So I'm going to choose t-test. And we have data or stats. We pick stats. So we pick stats. And then we come on down and there's mu 0. What else is there? Just x bar s sub x. Yeah. X bar s sub x. In so what's mu 0 on this one? Yeah, we always get that from the H0. X bar, yeah, the mean weight is 28.6. S sub x, standard deviation, 4.4. And in 16.
Not equal, less than, greater than thing.
Oh, yeah. So, yeah, and then we got to do less than, don't we? Because that's what's in H1. All right, so there we go. Put that information in. How we doing? We getting numbers? I'm getting, and all I care about really is the p-value, huh? I'm getting the p-value of 0.11. 0.11. I'll just go with that. 0.11. That's the p-value I got. And so now, how do we decide about the test? Got it. What do we have to do? The significance level. Got to put the significance level right next to it, which is 0.05. 0.05 significance level. And now, which one of those is bigger? Yeah, the p-value is the greater one. 0.11 is greater than 0.05. So is the p low? No, this p is greater. P is not low. P is not low. So if P is not low, then HO does not go away, right? The not with the not. So if P is not low, the HO does not go away. So that means HO is not going to go away, so I'm going to keep HO, and get rid of the other one. We good with that? You've done a fair number of these now. Getting more and more comfortable. So we keep the HO, and that means we conclude that the mu, the average, is equal to 30. It's not less than 30. We crossed out the less than 30, And there's what? weak evidence. See how we know all that? Let's go through the options now. So is it this first one? There's not sufficient evidence. Is that right? Not sufficient?
Yeah.
Yeah, we're talking weak evidence. Weak evidence. So yeah, so it's one of these not sufficient. I can cross off the two that say sufficient. No way, huh? It's one of the not sufficient. There's not enough evidence. Therefore, we conclude that the true mean is not less than 30. Is that right? Yeah. We concluded it's equal to 30. We crossed off the less than 30. That's exactly right. What's the other one that was wrong? Therefore, we conclude the true mean is less than 30. No, that was not right. It's not less than 30. We crossed off the less than 30. We said the evidence isn't strong enough to conclude that. The evidence is weak, so we stick with the original assumption that it's not less than 30. Is that good? To feel your ability to weigh a claim now with statistical evidence?
Are you possibly going to put one on the test where the claim is the...
To number 9 then. In a sample of 76 adults selected randomly from one town, it is found that 12 of them have been exposed to a particular strain of the flu. Find the p-value for a test to support the claim that the proportion of all adults in the town that have been exposed to this strain of the flu is 8%. Round your answer to 2 places. So this time, they don't want any of that conclusion stuff. All they want's the p-value. See how I'm just testing p-value on this one? So we don't have everything on any one problem. But you're still going to need to start with the claim, HO, H1. But then once you get the p-value, you're done. Doesn't matter what the conclusion is. What's the claim on this one? Let's start there. What's being claimed? That's a little tricky on this one. What's being claimed? Yeah, claim that the proportion of all adults in the town that have been exposed to this strain of the flu is 8%. Is 8%. Is that a percentage? Yeah, it's a percentage, huh? Feels funny even saying any other option. Clearly, it's a percentage, right? P equals 0.08. Not mu. In other words, not an average, is it? So there's the claim. Also, here's one right here. HO and H1. What's HO going to be? Yeah, the HO is always equals. So if HO is equals, what's H1 going to be?
Not equals.
Not equals has got to be the opposite. And which one of those is the claim? HO this time. Yeah, so here's one where... So HO can be the claim. Notice. So Zach was just asking me, that's a good question. HO can be the claim. So often, usually seems like it's H1, but it can be HO. All right, so, and then write our evidence in. I don't think we even really care on this one, actually, because we don't have to do that in stuff. We just have to go forward for the p-value now. So we're going to go, this is a, what is it? If we go to our notes, it's going to be hypothesis test for P, 1 prop Z test. So 1 prop Z test. It's going to ask me for P0, X, and N. So what's P0? Yeah, that always comes from HO, so 0.08. What's X on this one? Got 12 of them have been exposed. N is 76. And at the bottom,
Not equal.
oh yeah, you got to choose the not equal. That's important, huh? From the H1. Right, so type that into your calculator. And I'm getting a p-value equal to 0.0123, which rounds to 01, huh? Did you get that okay? Number 10. A large software company gives job applicants a test of programming ability, and the mean for that test has been 160 in the past. 25 job applicants are randomly selected from one large university, and they produce a mean score and standard deviation of 165 and 12 respectively. Use a 0.05 level significance to test the claim that this sample comes from a population with a mean score equal to 160. Find the p-value and round your answer to 2 places. So it's another p-value. So we got to start with the claim, though. So what's the claim here? What is being claimed? Test the claim that this sample comes from a population with a mean score equal to 160. Mean, there it is again. The claim is equals again. See how I just grab the word claim and just take the words that come right after it? Mean equal to 1. Mean is the Greek m, right? The mu. Mean equal to 160. And then we write our HO and our H1. What is HO always? Always equal. And so if HO is equals, what's H1 going to be? Not equals. And which of those two is identical to the claim? Yeah, HO. See, these guys match exactly. So I write claim by the one that matches the claim. And then I write the evidence words in. Really, we don't really need it this time. Weak evidence. Strong evidence. And then we go to our notes. We're right here. Hypothesis test for P, 1 prop Z test. So 1 prop Z test. And it'll ask us for, what is it, P0, X in, P0, X in, yeah. So what's P0? Oh, I'm doing the wrong thing. This isn't a 1 prop Z. You guys got to tell me when I'm being crazy. Let's try again. It's not a P. It's a mean. And is data given or not? No data given. Wait, I'm on conference. I am really having problems. Okay, hypothesis test, no data given, t-test. For a mean, right? This is for a mean, not a percentage. So it's a t-test, choose stats. Go back and do the right thing here. Not a 1 prop Z. It's a t-test. And when it says data or stats, I choose stats. And stats asks me for mu0, x, s sub x, x bar, s sub x in. All right, what's mu0? Yeah, it comes from the h0. 160. The x bar, hopefully they gave it to me. Yeah, mean and standard, 165 and 12. Mean 165, standard 12. What's n? Where are you seeing that? Oh, nice. Yeah, when they write words, it's easy to miss it, huh? 25 job applicants. There we go. And then, is this one greater than, less than, or not equal? Not equal. We're getting that from... It's got to match the H1, huh? All right. Now we've got it. Hit the stats. T-test. Stats. Not equals. Calculate. So I'm getting a p-value, which is really all I care about. Yeah, that's all they're asking for. P-value is 0.048. So it rounds to 0.5. Oh, it's not there?
No.
Disturbingly not there. 0.5. Is that what y'all got? 0.5? Questions on that one? Question number 11. An article in a journal reports that 34% of American fathers take no responsibility for child care. A researcher claims that the figure is higher for fathers in the town of Littleton. A random sample of 225 fathers from Littleton yielded 40% who did not help with child care. Find the p-value for a test to support the researcher's claim. So it's another p-value problem. This is 3 of these now. This will be the happy test, hopefully. So what's the claim on this one? Where is the word claim? Oh, there it is. A researcher claims that the figure is higher. Higher. So higher is going to be greater, huh? Something's greater. And is it a percentage or a mean? Lots of percentages on this problem, huh? So there's no means anywhere. Okay, higher than what, though? Yeah, because 34% is the average for all America, and the researcher's saying it's higher in Littleton, higher than 34%. Yeah, so there's the claim. That good? And then we jump into the HO and the H1. What is HO always? Always equal. So then one of those two has to match the claim. So the H1 must be greater than. That's how I know it's greater, right? That's how I know it's not equals. Right? That we had another one that was not equals. These last 2 or 3 were not equals. Why is this one greater than? Well, somebody has to be the same as the claim, don't they? So it has to be greater. Claim comes down there, and I write claim by that bottom one. And, weak evidence, although we don't even need it on this one. Strong evidence, just a good habit. But now we go to our calculator and go to our chart here. This is a P hypothesis test, so it is a 1-prop Z test. So we'll do that 1-prop Z test. And the 1-prop Z test, we choose P0, X, and N. So what's P0? 0.34. We always get it from the right here from the H0. And the X is what? Yeah, oh yeah. Heads up if you've been doing something else. Yeah, I looked at this ahead of time. That's right. I'm glad we're here. Yeah, I wish I could do cartwheels, but I would hurt myself and maybe some of you. Do whatever I can to get your full attention. Heads up. This is what gets people on the exam. And there's a couple of these. And there's only 15 questions. So if you don't get this, you just lost a grade and a half. Right? I'm not overemphasizing. Right? It's only 15 questions. So that means every question's worth about 7 points, right? It's not about 107 times 15. Yeah, close to 7 points each. I'm telling you, there's two. As I was going over the real exam, I noticed there were 2 of these, and I was like, oh, that's hard for students, but it's fair. It's on the practice exam. I'm just telling you, I've seen over the years that this is what stumbles students. This is one of the main things. They get right here and they get kind of frozen like a deer in the headlights. They kind of frozen. Sorry, that's a dramatic image, I know. But as the test is coming at you, they're like, what is the X? I don't see the X. He always gives us an X. Why is there no X? Right, sometimes you need to come up with it yourself. And that'll happen for sure on Wednesday. So, how do we do it? What is X? Well, first of all, how about we jump down here? What's N? 225, right? That's the total number of fathers, 225. Okay, we got that. That's good. That one's obvious. But what's the X? 40% of that. They're not giving me a number. I got to get it myself. X will be 40% of, which always means, what does that always mean? Times. Part of, which is times. 40% of the 225. Is everybody seeing this? Don't miss this. This will be very important to you in 2 nights. 40% of 225. See, they're not saying, 10 fathers out of the 225. They're saying 40% of those fathers. So we got to get that ourselves. So we got to change the 40% to a decimal, right? Whenever we use it in a calculation. Of is times 225. Whoops. And so what I'm getting is 90. So bring that over. X is 90. So we had to get our own X. You'll have to do that a couple of times on our exam. Does that make sense? Is that good? Now just put everything in. Oh, and the bottom thing is it greater than, less than, not equals. Greater than, because that always comes from the H1. So put that in your calculator. One prop Z test. It's going to be 0.34, 90, 225. Greater than, calculate. So I'm getting, all they want's the p-value, huh? So I'm getting a p-value equal to 0.0207. So just 0.2. There it is. 0.2. Oh, it's an 8. Sorry, it's just my eyes. It's not an O. Thank you. It's 0.287. I need more light for my old eyes. So that'll be 0.3. Thank you. So it'll be 0.3. We good there? Your own X. You'll be able to do that for the big points. All right. In tests of a computer component, it is found that the mean time between failures is 520 hours. A modification is made which is supposed to increase the time between failures. Tests on a random sample of 10 modified components resulted in the following times in hours between failures. And they got a list there for us. What do we do with those numbers? L1, like always, right? At the 0.05 significance level, test the claim that for the modified components, the mean time between failures is greater than 520 hours. Find the p-value and round your answer to 2 places. All right, let's start by putting those numbers into L1. Okay, so we got to start with the claim, right? So what is the claim on this one? Test the claim that for the modified components, the mean time between failures is greater than 520. Mean greater than 520. These are a lot easier than they were 2 weeks ago, a week and a half ago. Mean is greater than 520. And then HO, H1. HO is always equals. What's H1 going to be? Greater than, because one of the two has to match the claim. So that's where I'll write claim, because the second one matches the claim. And we'll put in our evidence statement, even though we don't really need it this time. Weak evidence. Strong evidence. All right, let's go to the calculator. I'll go to the notes here. So this is hypothesis test for a mean, and data is given. So if data is given, you put it in L1 and choose t-test. And then data, says the notes. Or it's even a little bit better to see right here. Data given, put the data in L1, t-test, choose data, and there's the rest of what we do. So let's go do that. So we'll choose t-test, data or stats. We choose data, and it'll say list. And so the list is L1. That's where we put our data. We're telling the calculator where to go grab the data list. It's in L1. Frequency is always 1, meaning each of those numbers only appears once. And we're going to do greater than here, aren't we? Because that comes from H1. So put that in there. Oh, and I forgot. Oh, it asks for mu0 also, doesn't it? Mu0 is 520. We get that from H0. So 520. List is L1, frequency 1. Choose greater than. And calculate. And so then I'm getting, after all that, I'm getting a p-value that is 0.014. So 0.01. Just like that. Number 13. A psychologist claims that less than 21% of the population suffers from professional problems due to extreme shyness. Assuming that a hypothesis test to support this claim at the 0.05 significance level has been conducted and that the p-value came out to be 0.0725, what is the conclusion? This is kind of nice. We don't even have to do anything on the calculator. But we do have to do the claim HO, and then just grab the p-value and draw the conclusion. See how on this one I'm just testing your ability to land the plane? We're not really flying it at all. It's just all about the ending, right? This way I can, test your abilities in all the different areas and not make it too long. So we don't even do anything on the calculator. But we still have to do claim HO. So let's start, and then land the plane is what it's really all about. So let's start with the claim. What's being claimed here? A psychologist claims that less than 21%, there we go, it's a percent, it's less than 0.21, isn't it? That's pretty clear. And then HO, H1, what's HO going to be? Equals, always. What's H1 going to be? Because one of them has to match the claim exactly. That one's matching the claim. And let's write weak and strong evidence. We will need that here. Weak evidence. Strong evidence. Okay. So they're giving us a p-value. What's the p-value? 0.0725. What's the significance level? Right there, 0.05. Because that's how we draw a conclusion, right? We put the p-value and down and the significance level to its right. It's always in that order. Notice I always put the significance level just to the right of the p-value. Which one of those is bigger? If it helps, add 2 zeros so they have the same number of decimals. Which one's bigger? The p-value is, right? 725 is bigger than 500. 07 is bigger than 05. So is that p low or not low? Yeah, that p's greater. He's not low. The p is not low. So that p is not low. So, what does that mean then? Well, if the p is not low, the HO does not go away, right? P not low, HO does not go away. So that means we're going to keep HO, aren't we? And the other one goes away. See how we're concluding that? Right? If the P is not low, then the HO does not go away. We keep the HO and cross out the H1. So our conclusion then, you can write it if it's helpful for you. Our conclusion is HO, which says P equals 0.21, and there's weak evidence for that fact. That's what we're concluding, HO. So now we can look at the words and see which words are correct. So it says there is not sufficient evidence. Is that right? Yes. Yeah, because evidence is weak. So let me cross out these two sufficient evidence answers. That's not right, is it? It's one of those not sufficient evidence answers. Which one is it? Well, let's read on. Not sufficient evidence, weak evidence, correct. Therefore, we conclude that the true proportion is not less than 21. Is that true? Yeah. See how we crossed off the less than 21 option? not less than 21, equal to 0.21. Yeah, that's it. The other one's wrong because it says true proportion is less than 21. No, that's not right. We canceled the less than 21. There wasn't strong enough evidence for that. How are we doing? Is that good? So that's testing your ability to understand p-value and draw a conclusion. Two more. Number 14. A manufacturer of a refrigerator system for beer kegs produces refrigerators that are supposed to maintain a true mean temperature of 47 degrees Fahrenheit, ideal for a certain type of German, how do you say that, Pilsner? Pilsner? The owner of the brewery does not agree with the refrigerator manufacturer and claims he can prove that the true mean temperature is not 47 degrees. Assuming that a hypothesis test to support this claim has been conducted at the 0.05 significance level and the p-value came out to be 0.1123, what is the conclusion? So another one of these, can you draw a conclusion when you're handed a p-value? So we didn't have to calculate that p-value. They're just giving it to us. But we got to do the conclusion. So the first thing, what are we going to start with?
Claim.
The claim. Put it up here maybe. What's being claimed on this one? Yeah, claims he can prove that the true mean temperature is not 47 degrees. So mu is what? Not equal. Yeah, to 47. That's what he's claiming. Everybody see that? That's kind of where we have a claim, a not equals claim. We don't have a lot of. We have those every now and then, but it's a little more rare. So there's a not equals claim. So HO, H1. What's HO always?
Equal.
Always equals. And what's H1 going to be then? Not equal, because one of the two has to match the claim exactly. In fact, that's the one. Let me write claim next to H1 because that's the one that's identical to the claim, isn't it? And then we have weak evidence and strong evidence. All right, let's go forward from there. So, and then they give me a p-value. So we're saying the p-value comes out to be 0.1123. What's the significance level? 0.05, like it usually is, huh? So which one of those is bigger? Yeah, the p-value is bigger. 0.11 is bigger than 0.05, huh? So is the p low or not low? P is not low. Right, p's greater, so p's not low. And the your favorite rhyme, if the p is, in this case, not low, the HO does not go away. So if the p is not low, the HO does not go away. So this is another one where the HO is not going away. So I'm going to circle HO. HO is not going away. The other one's going away. But HO is not going away. We're keeping HO. So what's our conclusion? Our conclusion is HO. Put it down here. Our conclusion is HO. And HO says mu equals 47. Weak evidence. Weak evidence. All right, so let's go through it. So let's try to find the right answer. Is it the first one? There is sufficient evidence. No, evidence is weak, so there's not enough evidence. So it's not any of these sufficient evidence answers. Cross those out right away. So there is not sufficient evidence? Right, not. Okay, let's do it. To conclude that the mean temperature is different from 47. Yeah, there's not enough evidence to conclude it's different. We concluded it's equal. There was not enough evidence to conclude it's different. We ended up saying it's equal. That's exactly the answer. Does that make sense on that? Yeah, so that you got to read that whole sentence in context. It can fool you. Right? Because if you just look at this back part and you go, different from 47, but it's saying, you go, oh no, it's not different, but that's what they're saying. It's not different. There's not enough evidence to prove it's different on that. There's our English units again, our reading units for this class, right? Reading quantitative material in context. Complex quantitative sentences. It's a good professional skill. Does that make good sense on that? We good there? Feel like you could do that on the exam for the big points? So practice that if that's confusing. We've got one more to go. One more to go. Hey, hold on for 1 second. We just have 10 minutes, but what if somebody was to say, oh no, we don't have there's not a good way to point that out on this one. All right. So, I can't do it. I'm going to move on. Yeah, never mind. I thought I could show something, but I can't. Question 15. The owner of a football team claims that the mean attendance at games is over 59,100, and he is therefore justified in moving the team to a city with a larger stadium. Identify the type 2 error for the test. Type 2 error. So again, we can't just dive, you probably think about the notes, and that's good. Type 2 error is number 5, huh? I put the type 1 and the type 2 error, but really before you do that, we'll see what it says. Failed to reject the null when it was false. So if I'm going to understand what that means, I've got to have the null. Right? So that's no good to me if I don't have the null. Right? It's saying, a type 2 error? A type 2 error is when you fail to reject the HO. Well, I don't even know what the HO is right now. So I have to first go back, find the HO, then I'll use that information. So how do you get the HO? You got to have the claim, right? Does everybody see? This is the mistake I see a lot of people make. They try to do these questions without doing claim, HO, H1. You have to. So what's the claim on this one? Okay, claims that the mean attendance is over 59,100. Mean over, what's over? Greater than 59,100. That's what he's claiming, isn't he? Saying the average is greater than 59,100. All right, so now we come down to the HO, H1. What's HO always? Always equals. And then what's the H1 going to be? Greater than. Because one of the two has to match the claim every time. So bring that down. That's the one matching the claim. Weak evidence for the first one. Strong evidence for the second one. Now let's go grab the type 2 error information and be clear on that. So it says type 2 error failed to reject the null when it was false. So type 2 error fail to reject the null when it was false. You should have rejected it. It was false. But you failed to reject it. You made an error. That's a type 2 error. So it's just like a court of law. They can let a bad guy go. That's a bad error. Or they can arrest an innocent person. That's definitely a worse error. Right? There's mistakes on either side. That's why we design these stats tests carefully when they test things. Anyway, so let's get to the question. So let's go through it. Fail to reject. Is this a fail to reject thing? Yeah, for sure. Fail to reject. So forget about these reject options, right? Or that one reject option. I guess there's just one. So it's one of the three fail to reject. I guess we've only eliminated one option so far. We're slowly getting there. It's one of the fail to reject. Fail to reject what? The null. Well, what is the null? That right there. Fail to reject that mu equals 59,100. That's the null. That's the HO. Now I know what the HO is. Failed to reject the HO. So failed to reject the idea that the mean attendance is more. No. Equal. Failed to reject the idea that the mean attendance is equal. Yeah. Failed to reject the mean attendance is equal. Oh, yeah. All those. So far, so this one's gone. Now we got 2 left. So I'm paring it down. Right? Failed to reject the null, which says it's equal. Equal. Now, to the final part. When it was false. It's false. The null is false. It's really false. The null is actually false. And that means the other one's true, huh? So what is it actually? Well, when it is actually greater. There it is. Not less. So that takes a little tracking, doesn't it?